All right, let's talk software architecture. But forget the dense textbooks, the ones that put you to sleep. Today, we're serving up a tasting menu. We're going to break down the core patterns that power pretty much everything you use online. And we're going to make them simple, intuitive, and maybe even a little delicious.
Yeah, let's just start right here. If you've never built it or broken it a few times, you probably don't fully understand it. This is everything. See, architecture isn't just some clean diagram on a whiteboard. Nope. It's the messy, real-world business of building something, watching it spectacularly fail, and then figuring out why. That's the vibe we're going for today.
So what exactly is on the menu today? Well, we're going to be slicing into giant birthday cakes, peeling back some architectural onions, and even listening in on a gossip network. It's all about exploring these really powerful ideas through simple, memorable metaphors. We'll hit deployment, code organization, and communication. So let's dig in. First up, deployment. Cake or cupcakes? This is probably the most fundamental decision you'll make. How do you actually get your software, your creation, out there for people to use? The choice you make right here, well, it really sets the stage for everything else.
So you've got two main choices. On one side, you have the monolith. Think of it as one giant birthday cake. Everything, the user interface, the business logic, the data access, it's all baked into one single application. You build it as one thing, you deploy it as one thing. Simple, right? But then you have the other option, microservices. These are your cupcakes. The system is split up into all these tiny, independent services, each doing one specific job. They're all separate, and they have to talk to each other over the network.
And this gets to the heart of the debate, right? The monolith is awesome when you're a small team or you're just building an MVP. It's way faster to get going. The advocate's argument is clear. It reduces complexity and makes debugging less of a nightmare. But the devil's advocate has a point. As that cake gets bigger and bigger, it can become this brittle beast that's impossible to change without breaking something else. This is the exact trap Spotify fell into, which led to their famous, massive migration over to microservices. They needed their teams to work independently and scale their own cupcakes, you could say. But as you can imagine, managing a whole bakery of cupcakes introduces its own kind of chaos. So it all boils down to this question you have to ask yourself. What are you really scaling? Is it just features, or is it your teams? Or is it just sheer complexity? Because if you're scaling features in a small team, the monolith might be fine. But if you're trying to scale the number of people working on the code, well, that's when you start thinking about those cupcakes.
Okay, so you've picked your deployment style. One big cake or lots of little cupcakes. The next course on our menu is about what's inside. How do you organize the code itself? Here, we've got two delicious options: sandwiches and onions. Let's start with the classic club sandwich, what we call layered architecture. It's a classic for a reason. It's all about neat separation. You've got your presentation layer on top, that's the UI. In the middle, you have the meaty part, the business logic. And at the bottom, the data access layer, talking to your database. It's clean, it's organized, but there's a catch. You have to be careful not to create layers that don't do anything. They just pass the data straight through. That's a sandwich with no filling, and nobody wants that.
So let's peel back a layer of that sandwich and focus on the really important part, the business logic. There's a really powerful pattern for this called hexagonal architecture, or as I like to call it, the onion. The whole idea is that your core domain logic, the secret sauce of your application, is at the very center, protected. Everything else, and I mean everything, APIs, databases, whatever, are just adapters that plug into the outside. This is a game changer because it makes your most important code totally independent of any specific technology. And that makes it super, super easy to test. Okay, quick recap. We know how to deploy our code, cake or cupcakes. We know how to organize it inside, sandwich or onion. But what happens when you have a whole bunch of those cupcakes? How do they actually talk to each other? This brings us to our next course, communication, which can sometimes feel like gossip and divorce. A really popular pattern here is event-driven architecture. And the best way to think about it is like a gossip network. Seriously, one component doesn't call another one directly. Instead, it just sort of shouts an event out into the open. Like, hey everyone, an order was just placed. Then any other component that actually cares about orders can listen in and do something about it. It's amazing for decoupling your services. They don't need to know about each other. But, and it's a big but,
Try debugging that. Following a piece of gossip through a whole network to find out where it went wrong? Yeah, good luck. Which leads us to this really important, kind of provocative question. Are you building a system or are you building a rumor mill? Because when you have events just flying all over the place with no clear owner, no clear order, you're not building a system, you're building chaos. It's an incredibly powerful pattern for sure, but man, it takes some serious discipline to get it right. Now, if the gossip network sounds a little too chaotic for you, there's another approach. I like to call it the strategic divorce. Its official name is CQRS. The whole idea is you split your application into two totally separate models. You have commands on one side. This is the write side. It's all about changing data, and its main job is to be safe and reliable. Then you have queries on the other side. This is the read side, and has one job and one job only, to be fast. Blazingly fast. This separation can give you a massive performance boost. But now you have a new problem. How do you keep the write side and the read side in sync after their divorce?
All right, time for our final course. Let's call these the finishing touches. These are two patterns that are less about the fundamental structure and more about refining how your system thinks and how it can grow in the future. We're talking language and Legos. First up is domain-driven design, or DDD. This one's more of a philosophy, really. The goal is to make your code sound like your product manager wrote it. It's about getting developers and the business experts to use the exact same language for the important stuff, like what a customer is or what a shipment means. When that happens, you start building software that actually solves the real business problems. Then you've got plugin architecture. Think of it like Legos. You build a really solid, stable core for your application, and then you can just snap on new features as plugins whenever you want, sometimes without even having to restart the whole thing. It's exactly how extensions work in your web browser. And that really brings us to the biggest takeaway from all of this. These patterns, they're not isolated islands. You don't just pick one. They form a connected ecosystem. You might have a system of microservices, your cupcakes, where each cupcake is built with a layered sandwich-style architecture inside. And at the heart of that sandwich is a protected onion core. And maybe all those cupcakes talk to each other using that gossip network. See? They all fit together. They're all tools in your toolbox. Which leads me to this final, crucial point. You can know the name of the architecture, but that doesn't mean you understand it at all. It's so easy to learn the buzzwords, Monolith, CQRS, Hexagonal, and throw them around in a meeting. But real understanding, that doesn't come from a vocabulary test. No, it comes from doing. So don't just name it, build it, and then break it. Go out there and actually use these patterns. Build something cool. See where it works like a dream. But more importantly, find out where it falls apart, because that is where you'll really start to understand. That's where the learning happens. Now, go cook something up.